This is quiz 15. Again, we were supposed to find a bunch of derivatives, and they're, again, chain rule problems where the functions are just a bit more complicated this time. So here we have y equal to the sine of the tangent of 2x. So dy dx, which I'm going to write as y prime, is going to be the derivative of the outer function, that's cosine, of whatever's there. So that's tangent of 2x. And then the chain rule comes along and says, now you got to multiply by the derivative of what's inside. So you have to remember the derivative of tangent, that's secant squared of whatever's there, secant squared of 2x. And then the chain rule comes along and says, wait a minute, that's not x, so you got to multiply by the derivative of what's inside there, and that's going to give you just a 2. And so that's it, and I wouldn't rewrite that. Okay, number 2, we're supposed to find dy d theta, where y is given as the secant squared of m theta. And here you have to know, since you're trying to find dy d theta, you have to know that theta is the independent variable. That makes m a constant. And you also have to know that secant squared really means secant of whatever quantity squared. So the derivative of something like this is given by the power rule. You could multiply it out and then use the product rule, but it's much easier to go 2 times whatever, just copy, to the first, and then say times the derivative of what's inside. Now you got to remember the derivative of secant. The derivative of secant is secant tangent. Secant of whatever, tangent of whatever. But then once again, the chain rule comes along and says, wait a minute, you got to multiply by the derivative of what's inside there. The derivative of what's inside there is whatever the derivative of m theta is. Well, m's a constant, theta is the independent variable, so we get an m stuck in there. And you could write this as 2m. I suppose we should consolidate this. This does simplify. So we're going to have 2m. That's not bad. But here you got a secant of m theta. Here you got a secant of m theta. So that's going to make secant squared of m theta times tangent of m theta. So if you didn't do this, I might get tempted to take off a point, because this is a simplification that you really should do. Maybe. I mean, you should do it, and maybe I'd take off a point, but certainly not more than that. Okay, the next problem, you're supposed to find y prime, where y equals e to the, I'm sorry, no, it isn't e, it's 2 to the sine of pi x. And here, to do this problem, you have to remember that the derivative of, with respect to, let's change variables just for fun, dt, the derivative with respect to t of 2 to the t is 2 to the t back again times the natural log of 2, the constant that you get because it's not e that you're taking as the base. So in this case, y prime, the derivative of 2 to any power, is 2 to that power back again times the natural log of 2. Now this works as long as the base is constant, and in one of the future quizzes, probably the next one, we'll be doing logarithmic differentiation, and there you deal with the situation where the base is a variable. But in this case, it's just 2 to that power times the log of the base. But the chain rule comes along and says you still got to multiply by the derivative of what's up there. So the derivative of sine of anything is cosine of whatever, pi x. But you're not done yet, because the argument is not just x. So you can multiply by the derivative of pi x. Pi, of course, is a constant, so you're going to get a factor of pi in here. So it doesn't look like any of this is going to simplify. You could gather all your constants together, pi, natural log of 2, times 2 to the sine pi x, cosine of x, but that's not worth doing. So that's it for problem 3. And then problem 4, you are given that h of x is this weird function, the square root of 4 plus 3 f of x. And they didn't bother to tell you what f of x is, but they told you that f of 1 is 7 and f prime of 1 is 4. So the question is, what's h prime? Well, they want h prime of 1. So to do that, we will first calculate h prime of x. And of course, the square root of anything is that anything to the 1/2. So the derivative of anything to the 1/2 is 1/2 times whatever, 4 plus 3 f of x, to the power 1/2 minus 1, which is negative 1/2. And then the chain rule comes along and says, you got to multiply by the derivative of what's inside. Okay, so what's the derivative of what's inside? The derivative of 4, that's easy, that's 0. Plus, so the derivative of sum is the sum of the derivatives. What's the derivative of 3 times anything? Well, it's 3 times the derivative of that anything. They didn't tell us what f of x is, so best I can do, f prime of x. Okay, so that's the derivative of h at x. But I'm not really interested in the derivative of h at x. I'm interested in the derivative of h at 1. So the derivative of h at 1 would be 1/2 4 plus 3 times f of 1 to the negative 1/2 times 3 times f prime of 1. And then you just have to fill in what the given information is. So this would be 4 plus 3. F of 1 was given to be 7 to the negative 1/2 times 3 times f prime of 1, which was given to be 4. So this is going to be 1/2 of, this is 21 plus 4 is 25 to the negative 1/2, and this is just going to be 12. And this actually simplifies. 25 to the negative 1/2 is 1 over 25 to the 1/2. And 25 to the 1/2, of course, is the square root of 25, so that's 5. So we get 1/2 times 1/5, which is 1/10. So you're going to end up with 12 over 10, which reduces to 6 over 5. And that's it for quiz 15.